All right, Steve, if you want to get started. So just for everyone who's on, so we're doing a Works with NX with Seagate, who we really recently did some pretty cool testing with, in terms of testing like camera throughputs to their storage devices. So and they were pretty cool tests. The fact that we managed to get 1,000 4K cameras all running to a single storage device. So we'll kind of talk more about the test towards the end of the presentation. We're going to start it off with Steve from Seagate, who's going to give us some background into the technology that was used and kind of the upcoming technology as well. That's going to make even more cameras probably possible to send to a single kind of storage array. So with that, I will pass it over to you, Steve, and you can get going.
Yeah, okay. Thank you, James. You can hear me okay?
Yep, perfect.
Great. Okay, so good morning, everybody, or possibly good afternoon if there's anybody sort of joining us from outside of the UK. So thanks for joining, and thanks to James and the Network Optix team for inviting us on another session. So let me get started. So yeah, so my name's Steve Jones. I'm Business Development Lead for EMEA for the video surveillance segment at Seagate. And today we're going to be presenting an overview of our recent tests completed in partnership between Seagate and Network Optix. So as James said previously, 1,000 4K cameras into a single storage array. So pretty impressive. The goal of this test was fairly simple. It was to test the limits of our Seagate 5U84 high density storage array. Looking at its performance in combination with the Network Optix VMS platform, using modern virtualization and, of course, our Seagate in-house storage technologies. James is going to later present the details of the test. First, I'd just like to take a short period of time just to introduce Seagate, look at some of the technology that's available today, what's sort of coming next, and how we're going to be looking at addressing the growing demand for high performance, high density storage solutions as we move forward. Many of you have maybe seen this this slide before. So a couple of years ago, the IDC Data Age 2025 report was published again by the research company IDC. This was actually sponsored by Seagate. And this really looked into, the global data sphere and how data or how data creation is going to grow over the coming years. We appreciate that not all of that data being created is going to be stored. And also that report looked at, the different trends and the different technologies that is really going to sort of drive that massive increase in growth. And one of them key trends and one of them key growth areas is IoT and video surveillance, and of course very relevant for today's presentation. Just to give you an idea as well, I mean, in the last 12 months, Seagate shipped approximately 450 exabytes of storage media. Now, taking into account that 1 zettabyte of data is 1,000 exabytes, 175 zettabytes is just a huge amount of data. And being a storage company, I think one of the main points that we want to get across, and with the acceleration of AI, deep learning, intelligent video applications, data is becoming what we would class as a world currency. There's a lot of value with inside data, and to get the best insights out of that data, you need, a good combination of good software platforms and, very robust storage technology and high density solutions. So Seagate is crafting the data sphere with groundbreaking technology. I mean, a lot of, I know, most people or most companies or most organizations would probably see and associate Seagate as a device manufacturer. but we are very much pivoting away from device and more into being known as a solutions company. And we really sort of believe that data has a huge amount of potential, and our goal is to really help maximize that potential by harnessing the Datasphere, and also to present best of class solutions that will help us scale and also deliver really secure solutions as we move forward. And also we cover various segments. I know today we're going to very much concentrate on the video surveillance segment, but again this Datasphere terminology that we use is very broad. And again, our focus is on providing the best technology, best of breed, high density and extremely secure solutions. So what's coming next? I mean, to really address that sort of scalability and that high demand, I mean, our current technology that us and our competition are using from a hard drive perspective is really coming end of life. So two technologies that we've invested in for many years. One is HAMR, which is heat assisted magnetic recording, and the other is MAC2. So HAMR is basically designed to enable the next big increase in the amount of data that can be stored on a hard drive. It uses a new kind of media magnetic technology on each disk, which allows the data bits or grains to become smaller and more densely packed than ever, while obviously remaining magnetically stable. We actually use a small laser diode attached to the recording head, and this basically heats very tiny spots of the disk, which enables the recording head to flip that magnetic polarity of each bit, enabling data to be written. MAC2, as we increase that areal density of our drives or of the media, this has, or this produces downward pressure on performance. And what MAC2 delivers is basically multi-actuator technology, which will more than offset these types of downward pressures. That means that the customers with data-intensive applications like video surveillance will continue to, really enjoy the highest levels of hard drive performance, while we increase that hard drive capacity. MAC2, which is our technology, is actually the world's first multi-actuator hard drive technology available on the market. And typically it delivers 2x performance increase compared to the current single actuator technology that we are currently using. And again, this technology is just about to be launched. So this month and very early part of next year, we're really going to start to ramp up and deliver this technology within inside our hard drives for the enterprise class space. Just a quick overview of our portfolio. This is quite important for the video surveillance market because our technology typically scales. Anything from the traditional NVR and DVR requirements that we see on sort of mainstream entry level CCTV applications. And as the performance requirement or manageability of the system or solutions increase, we then start to scale into more enterprise class, both HDD and SSD technology. And also today we're going to cover a bit more about our mass capacity storage platforms. This is the piece of probably Seagate that that most people are not aware of. We've been in this industry now for over 30 years, typically built through acquisition. You'll see two companies there, Dot Hill and Zyratex. And effectively, we've been providing these storage solutions into the market now for over 30 years. We've actually shipped over 1 million units. And when we talk about vertical integration, everything from design, development through engineering, even the ASIC design is all Seagate end to end. So we don't use any third-party manufacturer. and it's all in-house, and it's also a combination of both software and hardware. And again, I don't think, you know, Seagate are traditionally known within this space, but again, we've got 30 years experience, over 1 million units out there, and the test that James will cover in a bit more detail later on is actually using our 5U84 high density storage platform. Just to show you where these units are typically used existing, we're actually providing these high density storage units into the top 5 global OEMs. We also provide the leading top 5 cloud providers or hyperscalers. And these units are also, or this technology and solution is also used by some of the new emerging global technology companies for like autonomous vehicles, telco, media and entertainment space, and so on. Although we've got a range of different platforms, so we have JBOD, RAID, and the application platform. Typically with inside video surveillance, we really concentrate and focus on both JBOD and RAID. So JBOD, just a bunch of disks with typical SAS connectivity, and then our RAID storage, which we'll go into in a bit more detail, is our high density platform with dual redundant controller technology built in, and also a software stack with some additional features which we'll also cover during the deck. All our solutions provide modular design. So it's a very easy building block. You select your device, whether that be HDD or SSD, or a combination of the two, if it's a hybrid requirement. We have a range of chassis platforms, 2U12 up to a 4U106. And then we have a range of controller modules that then basically defines the connectivity to the unit. So an IOM is our input-output module, which is used for our JBODs and expansion BODs. Our data protection unit is used for our SAN, so this provides RAID protection. And then the compute element is used in our application platforms, more synonymous with sort of software-defined storage applications, and something that we're not actually going to cover because we don't see this particular product or this particular technology relevant for the video surveillance market at the moment. Just a bit of information about the RAID controllers. The RAID controller we actually used in the test is the middle unit here, which is the 4005. But you can see here across all the different RAID controller options that Seagate have in our SAN solutions or network attached SAN solutions, we have very high performance and also you know, a high availability from a connection point of view as well. So the 3005 controller can actually deliver sustained sequential write of 3 gigabytes per second. The 4005 controller that we have used in this particular test actually delivers sequential write performance, sustained sequential write performance of approximately 5.5 gigabytes per second. So you know, that equates in video surveillance terms to, you know, potentially hundreds, if not thousands, of HD cameras. And again, James will go through the test results that we've done with Network Optix towards the end of the presentation. Host connectivity is typically either 16 gig fiber channel or 10 gig iSCSI. You've got multiple ports, so there's 8 ports on the back of the units, and you can also share them ports across fiber channel and iSCSI, so effectively 4 ports on each. So again, high availability and a lot of connectivity options. From a software point of view, you know, what's our sort of USP? Well, we have 4 that we position with inside video surveillance market. We have a very specific streaming technology, which allows us to ingest, you know, huge amounts of, you know, unstructured data. We have a very specific way that we actually cache that data before we actually write it to our own spinning disk. A is for adapt. So adapt is an erasure coding technology, which again is Seagate IP. And this erasure coding technology effectively shares or splits the data across all the drives in a drive pool. And what this allows us to do is massively increase the rebuild time compared to traditional RAID. In fact, up to about 95% quicker than traditional RAID 5 or RAID 6. And again, this delivers, some real value add to the video surveillance market, because typically we always see some form of RAID specified into, larger, more enterprise class solutions. First to market, the fact that we own, the technology, and we build and engineer the actual technology, we'll always release it into our products first. And the encryption side, we have a suite of security features, typically under our self-encrypting drives, which basically delivers data at rest protection and security compliance for customers that require that higher level of security. And just to give you some examples, government establishments, finance are typically two sectors that use the Seagate Secure portfolio. From a scalability point of view, this is where our systems typically scale to in capacity size. So we recently launched the 18 TB Exos enterprise drive, which is now, which is now fully integrated into all our high density solutions. So you can see moving left to right, we have the ability to scale up to multi-petabytes onto our single SAN storage units. When we start to talk about SAN or network storage, traditionally when we look at, traditional CCTV, CCTV has always been fairly siloed. Single or multiple appliances where the appliance actually has the storage built in. But as systems start to scale, either in terms of camera numbers or availability or data retention times, there is more of a need to provide a SAN or a network storage type solution. And the reason for that, well, there's several. We move away from that no single point of failure. You can add storage as you need it, so you've got more scalable performance. And also, depending on the size of the system, we can also dramatically lower total cost of ownership. So we always deliver, the highest throughput in terms of performance, high availability and durability, and also a very easy way to manage the system. And the way we typically do that is on our SAN solutions, we actually provide a web-based management interface that allows you to easily configure, set up, and also manage the system once it's deployed and active. Typical, SAN or network attached architecture. Again, when we see appliances, there is that option to have the appliance embedded with the storage. But again, as we start to scale, the option to have, separate decoupled storage architecture definitely presents, many advantages in terms of, scalability and performance deliverability. We have a couple of integrations with Network Optix. On our device side, we have on our Skyhawk and Skyhawk AI, Network Optix have actually developed an integration into our Skyhawk health management feature set. And of course, on the system side, James is going to cover the test that we did recently on the 1,000 cameras. And just to sorry, and just to finish, again, we just like to just cover again, you know, our unique selling proposition. Again, you know, we're not just a hardware company. We have, you know, a development within software, and we deliver a software stack within all our high density solutions. So again, this safe terminology that we use, you know, S is for streaming, you know, streaming optimization, which is extremely important for video surveillance. Adapt, where we can actually deliver up to 90 or 95% faster rebuild time compared to traditional RAID. We have the first to market approach because we actually design, develop our own technology and feature set. And we also have a Seagate secure portfolio, which allows us to provide encryption and on-the-fly data at rest protection. So thank you for listening. I'm now going to hand over to James, and James is going to cover the details of the test and you know, what results we actually delivered in terms of performance and throughput. So James, over to you.
Yeah, thanks, Steve. As always, a very informative presentation. Can you just confirm you can see my screen okay? Yep,
fine.
Perfect. All right. So yeah, we'll just jump into kind of how we did the testing and kind of what we used and what the results were. So you can see kind of the goal of the test was to see how much throughput we could kind of get on the Seagate 5U84, the high density storage array. From my understanding, you guys had done like a 700 camera test prior to this, and you wanted to try and boost it and get to 1,000 cameras. The previous test was obviously not done with us, but with our new relationship, we kind of thought it would be good to see how we can really push the boundaries and see what we can do. So it was kind of the main goal of doing it. We also wanted to see kind of how much NX can run on a single virtualized server. So just a quick overview of what we used. We used a Dell R740. The main thing to take note of is the fact that we used 2 Xeon Gold processors, and then the Dell power switch. So this is just kind of like a quick overview. For those of you that are interested, feel free to download this presentation. You can get all the information. I'm not going to cover it in detail now, but it gives you an idea of kind of what the setup from our side was to be able to push 1,000 different cameras with one server to a single storage array. So a quick description of what storage array was used. So we used the Seagate 5U84. We had 84 8-terabyte drives in it, right? So a fair amount of recording capacity. And the main thing to note is there was I think you have 2 RAID controllers, not 2 RAID, 2 RAID controllers in this machine, right, Steve?
Yeah, correct. Yeah. And the setup, as you said there, the setup is active, dual redundant RAID controllers, correct?
Yeah, cool. So obviously it helps us with the kind of throughput on the machine. And then iSCSI ports for 10 gigabits of speed. So pretty vast device. We actually, in the testing, kind of didn't really hit the extremes of what the device could do itself. So you never know, there might be a second part of this test to see if we could do even more cameras than 1,000. So we'll keep an eye on that. Just an idea of the kind of software that was used. Again, we won't go into too much detail. You can grab this presentation to review it properly. One thing to note is we used something called TestCam. For those of you that aren't aware of it, it's our camera emulator. So the idea is we didn't have access to 1,000 cameras, so we can actually emulate the cameras and their streams as if they were live cameras. So that's also something that's pretty cool, because the Dell server was emulating 1,000 cameras as well as recording the 1,000 cameras, all across different VMs. So 10 VMs for the test cam and 10 VMs for NX Witness, all separated out on one machine. So definitely reckon if we had 2 machines, we could probably push the boundaries and see how far we could get with the Dell system. Here's an idea of how it was all kind of the architecture was set up. So we had the desktop client was connected via our cloud monitoring application. So you basically just had to connect from anywhere in the world. We could connect this. I had access to this. Our other sales guys all had access to this just via the cloud. Inside the single Dell machine, you can see we had, as I said, 20 VMs on a virtual switch. 10 of them were using the test cam, which were running on Windows. And 10 of them were running on Linux with NX Witness Server installed, doing the recording and the management of the system, all on a single Dell machine. And then all of that was being pushed via a 10 gigabit connection to the Seagate devices, or single device, actually. I shouldn't say plural. So scenario one, we did 1,000 1080p cameras was the start. We thought that would be, quite a push for the system. And most people, I think 1080p is still probably the most popular camera out there. So for those of you that know, we always take 2 streams from the camera. We always take a secondary stream as well. So we had basically, rather than 1,000 streams, it was technically 1,000 cameras with 2,000 streams. The primary stream being 1080p at 30 frames per second, and the secondary stream being a 480p stream with 7 frames per second. So you can kind of see how that was all set up with the information below. So there was no local capture. It was all pointed directly to the Seagate storage device for the default recording. And this was done over a 24-hour period and monitored to see what the kind of results would be. So you can see the results here over the 24-hour period. You can see there's a few snapshots there. There's the Seagate snapshot of their device, and then in the background you can see our devices breakdown as well. So the average CPU usage on the Dell machine itself was 43%, and you have to remember that is generating 2,000 streams and capturing 2,000 streams on 20 different VMs. So pretty lightweight on the NX side. Our overall throughput was 735 megabits a second, and that's obviously all pushing simultaneously to a single Seagate storage device. And you can see we had 0.001% dropped frames, which probably was nothing to do with the connection between NX and Seagate. It was probably the test camera software dropping a frame versus anything else. So pretty much no frame loss, 99.999% successful frame capture over a 24-hour period with 1,000 cameras, 2,000 streams, all being directly recorded to the Seagate device. And apparently, according to the report, which we haven't actually included in this, they did a drive failure test as well. So those success rates include someone physically pulling a drive out of the Seagate device and putting it back in, and it had absolutely no impact on the recording, the speeds, or any data loss at all. So pretty impressive functionality from the Seagate device there, to not even kind of see that a drive's being pulled out and pushed back in from the data perspective. So here's a quick breakdown. You can see it was only the NX1, the top server, that lost 0.01% frame. The CPU was 38% on that one. So like I said, it was probably an anomaly with the test camera software versus anything else, as there's 0 frame loss on every other single VM. So pretty good results there. So because those results were so good, we thought we should probably push it, right? So this is why our testing kind of extended and took longer than we anticipated, because as usual, our techs got a little bit too excited and we're like, well, that barely made a blip on the throughput, so let's crank this up. So we went for 1,000 4K cameras, right? So pretty much everything's the same except for the stream rates have changed. So our primary streams now, we're using 4K camera resolution for the primary stream and 30 frames per second. Also, our secondary stream goes up in resolution. So we're using 640 at 7 frames per second. Before we used 480 or 410 at 7 frames per second. So we've increased both streams, and everything else obviously set up the same way. We're recording directly to the Seagate array. So we've got effectively, again, 1,000 cameras, 2,000 streams, but a lot more data coming through. So let's see what the tests were. So you can see that the data has pretty much doubled, right? So we had 700 and something megabits per second before. Now we have 1,488 megabits a second. So roughly 1.5 gigabytes a second. And again, we only had a 0.005% dropped frames. So we had a 99.995% success rate. And again, I doubt the drop frames has anything to do between NX and Seagate. It may be to do with the test camera software or anomaly in streams. Because from my understanding from Danny is what's your max throughput on this device with your active RAID cards, Steve?
On this controller, on this test, it was 5.5 gigabytes per second sequential throughput. Yeah,
that's what I thought. So, yeah, we're barely touching it with 1.5 gigs, right? So, I think we might have to go back and do a 2,000 camera test.
Well, we've got some new technology. Can't talk about it at the moment, but there is some new technology that is due out next year that will give a few X increase in performance on our solutions as well. So yeah, so we can maybe do some other tests once we've got that new technology launched. Quite exciting. Yeah,
and we'll do them locally in EMEA rather than in Singapore as well.
Yeah.
But yeah, so you can see again, success rate is on point. Like you won't even see the frame loss there, right? It's and like I said, I highly suspect it's probably to do with the test camera application versus the connection between NX and Seagate itself. So you can see the breakdown there. Some servers had 0% frame loss, and we had 4 that had some frame loss going on. And you can see the CPU usage from the server side is really starting to hit its higher kind of level of usage, which is why I think we probably capped on the 1004K cameras. But again, that's purely because we're also streaming these on the same server as well. If it was purely just an NX capture device without actual streaming of cameras, those CPU usages would be drastically lower than they are. So in conclusion, basically we can record a lot of cameras to a Seagate storage array, but the main kind of purpose for what we were trying to achieve is a lot of people are talking about VSAS solutions at the moment, and kind of the best way to do that and the best way to manage the storage. So what we wanted to show was how well NX can kind of run in a virtual environment in terms of CPU usage, the amount of cameras you can put on a single machine via all running VMs on a virtual switch, and how well that data can be recorded to a large storage array like Seagate's to basically create a solution that it doesn't necessarily have to sit in the cloud per se in terms of your traditional thought of the cloud in terms of Amazon or Google. It could also be a Dell server and a Seagate storage array sat in a head office with a high level connection in whatever country you may be in, and that can also run as a VSAS model, right? So the main kind of like proof of concept is to show that you can run high levels of cameras. We did, like I said, 1,000 cameras or 2,000 streams, 4K at 30 frames per second, basically on a single server, recording to a high density storage array from Seagate, all in a single location in a data center in Singapore. So we're kind of like experimenting more with the VSAS side of things, especially as it becomes more and more of a hot topic, and kind of show the possibilities and the capabilities there. And as I'm sure anyone who's a NX enthusiast knows, we can also do the distributed kind of Hive architecture and have all that pushing back to a high density array from Seagate as well. So it's kind of it's something that's like I said, it's a hot topic at the moment, and it's part of why we did the test to kind of show what's doable, and kind of give people some food for thought on creating these VSAS solutions. I don't know if you want to add anything to that as well, Steve, on terms of the testing and your thoughts around it.
Yeah, yeah, of course, yeah. I mean, well, I mean, the testing really proves. I mean, it's always proof in the pudding, isn't it, about scalability? You know, many customers ask when we start to get involved in fairly large projects, you know, what the capabilities of the system are, and it's easy to look at that in terms of you know, scalable capacity, but you've got to deliver the right performance. There's always a bottleneck in the system somewhere, and I think traditionally, you know, probably on smaller type projects, you know, we still see the traditional approach where, you know, you have a single NVR stroke recording appliance where, you know, the installer loads the VMS recording software. But basically you have the compute and the storage combined in the same box. And, you know, depending on the architecture or the system design, you know, future scalability and growth of the system, you know, that type of, you know, hardware architecture is fine. But as we see systems starting to scale, you know, the introduction of, you know, hosting video or transferring video or even duplicating video in the cloud, and more private cloud types of applications, you know, the requirement for, you know, network attached storage is definitely growing. And I think what this you know, test really proves is that, you know, you can combine that high capacity scalable offering, but also deliver, you know, huge performance. And that huge performance is also delivered, you know, with sort of, you know, the lowest total cost of ownership. You know, in the storage industry, you know, dollar per terabyte is always being driven down. You know, the expectation from some of the big cloud service providers is they want, you know, huge amounts of performance and throughput feature set in a single HDD at the highest capacity. You know, we're talking 18 TB now. You know, next year we're going to be seeing, you know, 20 terabytes plus in a single hard drive, and over the next few years we'll be seeing, you know, multiple X times that capacity in a single drive. And these types of hyperscalers want that technology packaged in a 3.5-inch format, you know, to last for 5 years or more for very little cost. You know, and, you know, we've always been at the forefront of developing, you know, the latest technology, delivering the highest performance. You know, I mentioned before Hammer, Mac 2, both them technologies are going to be available in our storage platform. But what we're looking at is to balance, you know, cost, performance, reliability, security. I mean, security is key. You know, secure data is absolutely critical, especially in video surveillance, and more so with specific, you know, verticals that we discussed before. You know, finance, government being just being, you know, two examples. On this particular test as well, I mean, the 84 bay unit that we used, I mean, typically it's split up into 2 racks. So it's a single storage array, 84 bay. The 2 84 bays are typically split in half. So we have a 42 bay on top, 42 bay underneath. We have dual redundant power supplies, enterprise class dual redundant active controllers. The throughput or the performance is actually across the box. So effectively it's across 2 controllers. And how these systems are typically set up is, you know, you create some load balancing and create, you know, several storage pools, and effectively share them storage pools across the 2 controllers. But of course, in terms of redundancy, if there is, you know, an unexpected error or there's a requirement to replace one of the controllers, you know, everything effectively fails over onto the redundant, you know, working device. So you know, when we say HA enterprise class, you know, high availability enterprise class, you know, we use this 5 nines, you know, the 99.999% availability and sort of, you know, dependability, and that's what these types of systems deliver. But in terms of, storage capacity, the 84 bay with the 18 TB delivers about 1.5 petabytes in a single enclosure. But if you want to scale that, we can actually add on 3 additional expansion bods. So effectively, you're adding JBODs onto the same SAN. So you're using the same 2 controllers, you're using the same software platform, the same management interface, but you can effectively scale your storage. And that scalability currently with the 18 TB allows us to increase storage up to just over 6 petabytes on a single SAN architecture. So yeah, I don't know. Anyway, I don't know if there's any. Is there any questions from?
None at the moment.
Okay.
But yeah, we'll kind of talking about like the why kind of side of things. Obviously, this was a kind of high level technical overview about what's achievable. So I think Steve and I already discussed it, and we'll be doing kind of a more presentation focus on the why and the business cases behind kind of why these solutions are kind of becoming more at the forefront of people's minds, and kind of the way that there's a shift going. So catch us obviously early next year probably, and we'll be doing more about the why kind of for these solutions, so you can get a better understanding of the advantages versus a traditional architecture. So for those of you that are interested, keep an eye out for that for sure.
Yeah, I think we should look at maybe some of the typical like use cases as well.
Yeah,
which I think would be beneficial.
Yeah,
Definitely.
for sure.
Yeah.
So the one thing that we'll add on the end here is the Datasphere event from Seagate. We were one of the partners on that, actually talking about VSAS as well. But there's a whole host of information. If you jump onto the Datasphere event, as it says, it's access on demand. So you can just watch any of the videos all about kind of technology and the way that data kind of is being managed and stored. And the kind of future trends for that. I don't know if you had any involvement in the Datasphere, did you, Steve?
Not direct involvement. It's something that we highly promote. You know, it's a downloadable report. It's quite complex and in depth, but it really gives some really good insights in terms of, you know, data growth, data management, and where we can potentially, or where organizations and enterprises can effectively monetize that that data and make it more of a business proposition than I mean, in terms of video surveillance, you know, we always look at video surveillance. You know, in the past, it's always been a security product, and now it's being used in so many different ways. You know, so this report really highlights the sort of business approach to data, and also data insights. But yeah, just go onto the website if anybody's interested. Download the report. The virtual event is available on demand. You know, there's some real keynote speakers, a lot of our partners, including obviously Network Optix. So yeah, just everything's available on demand. Just go to seagate.com and yeah, you'll find all the information there.
Yeah, for sure. And then if anyone's got any questions, feel free to use the Q&A. Nothing's come through yet. As I said as well, we'll have the presentation available online at my.networkoptix.com. If you want to download it there, and it'll obviously have the links to the Datasphere and all the information in it in terms of more details that we kind of skipped over with the setup of the entire kind of solution, if you're looking at doing a similar VSAS test at all. So we'll give it a couple of minutes to see if anyone asks any questions. If not, then thank you everyone for coming on today, and thanks Steve for the presentation. Very informative as always, and I'll look forward to doing our next one together as well. Yeah, and thank you. Thanks for the invite again. But again, look forward to maybe creating one which is a bit more specific on use cases, and as you say, that the whys and where this type of network storage can really be deployed and where it really adds value in the video surveillance market. So yeah, thanks again. Yeah, 100%. All right, I'll give it another minute just to see if anyone asks a question. If not, then I'll say goodbyes and hope everybody has a great day. Looks like most people have dropped off now. So, all right, thanks everyone for joining. As I said, I hope everyone has a great day, and let us know if reach out to us if you have any questions or anything like that. And I'll hand it over to Steve just to finish up.
Yeah, thanks, James. Thanks everybody for joining. Yeah, again, thanks for joining. Thanks for spending your time, and hopefully we'll see you again some part in the early new year. Thank you.
Cheers, everyone.